Good evening, and thank you so much for attending this presentation tonight. My name is Mark Klapach-Mathias, and I am here representing two of the sponsors for tonight's event, including the University of Wisconsin River Falls and Hope for Creation. I would like to start by mentioning our next event, which will be on Thursday, February 4th at 6 p.m. and will feature the Lieutenant Governor of Wisconsin, Mandela Barnes. He will be presenting on the Wisconsin Climate Task Force. And please save the dates for our March and April presentations as well. The March 25th event will feature Tia Nelson, and the April 21st event will feature Dr. Terry Root. Before I hand things over to Dr. Overpeck, I would like to acknowledge the sponsors for tonight's presentation. Our first sponsor this evening, and the host for this series, is the River Falls Public Library. The River Falls Public Library enriches lives and builds community by connecting people with information, ideas, spaces, and opportunities. We are so thankful to have this library as part of our community and appreciate their ongoing efforts to host events highlighting climate change. The next sponsor is the St. Croix River Association. As the official nonprofit partner for the St. Croix National Scenic Riverway, the St. Croix River Association creates opportunities for people to experience and care for the St. Croix and Megagon rivers. They work throughout the St. Croix watershed to protect and enhance the natural park that flows through its heart. More information is available at www.stcroixriverassociation.org. Another sponsor is Powerful Choices. Powerful Choices is a community-wide effort to instill a strong local conservation ethic while demonstrating the importance and effectiveness of conservation, energy efficiency, and renewable energy. Powerful Choices, a department of the River Falls Municipal Utilities, recognizes that utilities play a large role in finding solutions to reduce humans' impact on climate change. Co-sponsoring talks and community events like this is an example of how we are listening and turning it into action. The School District of River Falls, an innovative leader in personalized learning, ensures the development of every student's unique potential in order to excel as responsible, productive, global citizens, facilitated by forward-thinking staff in a safe, nurturing, and collaborative environment. The University of Wisconsin River Falls Office of Sustainability endeavors to engage students, faculty, and staff, as well as the wider community, through hands-on educational and volunteer opportunities to further expand our shared integrity as socially, economically, and environmentally responsible citizens. We do this through hosting campus events, partnering with community events, and working collaboratively across campus and beyond to improve sustainability in all of its facets. Our final sponsor is the River Falls community group, Hope for Creation. Hope for Creation is a group of area churches with representation from the City of River Falls and the University of Wisconsin River Falls, partnering together to create a hopeful, sustainable future through collaboration, education, advocacy, and action. Hope for Creation acknowledges the urgency of our environmental challenges and seeks ways to protect the earth, our common home. Hope for Creation supports the deeply rooted values of our faith traditions, which call us to respectful stewardship of the land, air, waters, and all living things. Thank you again to all of our sponsors for your hard work in our community and our region. If any of the viewers tonight would like to get in touch with any of these organizations, feel free to email sustainability@uwrf.edu, and we can send you contact information for each of the organizations. Many of these groups also have websites and Facebook pages. It is now my pleasure to introduce our speaker tonight, Dr. Johathan Overpeck. Professor Overpeck is an interdisciplinary climate scientist, William B. Stapp Collegiate Professor of Environmental Education, and the Samuel A. Graham Dean of the School for Environment and Sustainability at the University of Michigan. He has written over 220 published works on climate and the environmental sciences, served as a Working Group 1 coordinating lead author for the Nobel Prize-winning IPCC Fourth Assessment in 2007, as well as many other awards. Dr. Overpeck has led climate research programs on 5 continents, focused on understanding climate variability, drought, and mega-drought dynamics and risk the world over. He has appeared and testified before Congress multiple times, is a fellow of the AGU and the American Association for the Advancement of Science, and he tweets about climate-related issues from the handle @GreatLakesPeck. Thank you, Dr. Overpeck, for presenting tonight. I now hand it over to you.
Thanks, Mark. Let me switch into, oh, you got it. That's excellent. Just have to, there we go. It's great to be with you this evening. You got to see that picture of me with a tie. That's definitely a pre-pandemic occurrence, and also a haircut. I'm waiting until I can get the vaccine and get back to the barber, I guess. So thanks for putting up with that. And it's also really wonderful to be back in Wisconsin, at least virtually. Some of my earliest research work was in Wisconsin back when I was a Ph.D. student and collaborating with colleagues at the University of Wisconsin in Madison, working on the vegetation and climate history going back thousands of years in Wisconsin. So it's cool to be returning to the Great Lakes. I lived out west for 20 years and just recently moved back to the Midwest where I spent my childhood. So it's really pretty cool to be doing that. And tonight what I want to do is draw a little from my experience in the West as well as in the Midwest to give you a sense of what's going on with the climate, how we know what is happening, a little on that, and what will be happening in the future, what the stakes are. And at the end of the talk, I really am going to emphasize hope, because I think there is a lot of hope for tackling this problem, particularly now that we have an administration in Washington that's taking science and climate change seriously. What you see here is a juxtaposition of a little lake off of Lake Michigan. So I'm looking at Wisconsin through that little gap, and on the left, and the other picture with the horse on the right is the Rio Grande in New Mexico, where my folks lived when they retired. What I want to do first, though, is talk about what's going on in the climate system. What you can see here is really one view of climate change around the planet right now. Obviously, we've had record wildfires this last year in both California and Colorado, and some huge fires as well in Arizona. But at the same time, the Amazon's burning almost like never before. Australia, a year ago now, was wrapping up its worst fire season ever. And remarkably, all the way up to the Arctic Ocean almost, the boreal forest, the circum-Arctic boreal forest, goes around from Alaska through Canada all through Eurasia, is now melting and drying out and burning. And some of these fires, I've been told, are actually going right through the winter under the soil. And what I want to ask everyone to think about is, what are these fires on the top here, the same ones that are not just burning forests, but are killing people and destroying communities? What do these fires have in common with some of the other climate extremes that we've seen recently? So, for example, in 2019, there was a horrendous heat wave in India. And last summer, a even worse heat wave in the Southwest United States, where in Death Valley, we broke the all-time record, 130 degrees Fahrenheit. So just incredibly hot, in Phoenix, over 200 people died from the heat last summer. You had the South African drought a little before that. It's just never really ended, but it's gotten a little better recently. And of course, all these hurricanes. 2020 was notable for the most hurricanes and landfalling in the United States. But you don't have to go back much further to find some unbelievably expensive disasters associated with hurricanes like Harvey or Katrina. So question, all of you, what do these things have in common? Warming. The warming of the planet is making all of these natural, quote unquote, disasters worse. And this is a really important point. And the reason it's so important is because we know with great confidence what is causing the warming. And therefore, we know with great confidence what is causing these natural disasters to really become human natural disasters, to become supercharged natural disasters. And again, Scientists have confidence in lots of aspects of global warming and climate change. But really, one of our strongest, best known, almost with perfect confidence, uh, pieces of knowledge is that humans are causing the Earth to warm, and that warming is exacerbating all these disasters. So you'll see why that's so important as we go on. Here's a map just updated today showing the trend. I didn't change the title. Ugh. But anyhow, this is the trend up to 2020. If you're watching the news, you know that we finally, places, NASA, NOAA, the other places that keep track of global temperature from thermometers around the world, have compiled 2020 now. We know, according to NASA, that it was tied 2016 for the warmest. NOAA said it didn't quite make it. Japan said it was the warmest ever. You know, when it really come down to it, it doesn't matter. It's at least one of the very warmest years ever. And very notable because there wasn't an El Nino, which is a phenomenon in the Pacific Ocean. When the Pacific Ocean warms, it always warms the planet another degree, 0.1 degrees C or so. And so to get a record year without an El Nino is really something. And if you look at this map, all the warm colors, yellow through red, are where it's warming. And you can see right away why we call it global warming. The areas that are gray, those are areas where the thermometer record doesn't go back to the 1880s. But we know that the Arctic is warming twice as fast as the rest of the planet based on shorter records. And we know Antarctica is also warming dramatically. Now, the globe as a whole, the lower atmosphere where we live, has warmed 1.1 degrees C. You can always multiply degrees C by 1.8 to get degrees Fahrenheit if you really want to. And so note that even though the whole planet is warmed about a degree, there are places on the planet that have warmed a good deal more, particularly over land. And the whole idea here is that, like politics, climate is local, right? So the Arctic is warming the most. That's because of melting snow and ice is less reflective and absorbs more heat from the sun, more radiation. Land also is warming more than the ocean for a variety of reasons that we understand pretty well. The last 5 years were the warmest years. The last 6 years were the warmest six. Essentially every single decade is warmer than the previous decade. It doesn't mean every year is going to be warmer than the previous year, though. There's natural variability in the system still. So we've had global warming about a degree C. And if you've been following the debate about, well, we should be in Paris Agreement or not in the Paris Agreement, the reason President Biden has rejoined is because he believes, as scientists do, that we can't afford to warm the planet more than 1.5 degrees, or at worst 2 degrees above pre-industrial, which is, of course, when the Industrial Revolution began, 1750-ish. So we really want to try and keep the global warming down, and we have to really move fast if we're going to do that. Okay, so I want to talk first about why. What's at stake, particularly in the Midwest, but I'll talk a little broader too. Okay, and I'm going to emphasize this is not my only picture of a fish. I'll talk a little about fish in Wisconsin near the end of the talk. But you can also see that there are other things going on in our system that if you're paying attention to the news, almost weekly, there's some climate disaster somewhere in the world, and these disasters are becoming more severe and more frequent. I'm going to emphasize the water cycle. And I'm going to do that because, to me, there are many aspects of climate change, the warming. Okay, and you're going to see in my presentation that the warming, the thing we have all the best confidence in, is having a pronounced effect on the water cycle. Okay, and I'm calling this the sharp edge of climate change. I'm emphasizing this because in the United States, this is where the rubber hits the road in terms of the biggest damages. And I'm not even going to talk about sea level rise, where the oceans are coming up faster and faster now as the ocean warms and expands and the ice sheets melt. I'm going to talk about rain or lack thereof. And a key part of this is as the atmosphere warms, it can hold more water. It can hold about 7% more water for every 1 degree C rise in temperature. It might not seem like a lot, but you're going to see in a second that it's having profound effects on our climate system. And the other thing to realize is that it's not just something that we know theoretically based on simple physics or based on climate models, but it's something we can actually observe. Everything I'm talking about today is happening, and we can see it in rain gauges, thermometers, and the like. Okay. So by putting more water in the atmosphere, the first thing that means, particularly if you're living out west or care about anything out west, where it really is hitting hard, is that we'll have more frequent, longer, and more severe droughts. Let's see what I mean. Here's the most recent drought monitor image. This is something that is a partnership between universities and NOAA, the National Oceanic and Atmospheric Administration. Every 2 weeks, they publish a new map based on observations of drought status around the United States. And I'm not showing you Alaska and Hawaii here, but you can just see that the real serious drought is out west. Where I used to live in Arizona is almost completely an exceptional drought, the worst drought. And what's interesting about this is that the drought started, interesting enough, in 1999 when I moved to Arizona. And so when I gave talks out there, I'd usually joke about that. But, you know, I'm a climate refugee. There's some serious bad stuff happening in the Southwest now. And one of those things is, you know, threatening water supply. But the other is just unbelievably hot temperatures in summer. So this is the first mega drought, meaning multi-decadal drought, that we have since we started measuring rainfall and snowfall with rain gauges. Here's just a depiction of how that drought's changed through time. So we're looking at that same drought monitor for different intervals in summer, in this case. 2002, the drought was, again, it's always in Arizona, it seems, but it moves around. And it was more up in Colorado. In 2012, on the lower left, you can see where it moved out on the high plains. It really looked more like a Dust Bowl drought. 2013, anyone who knows Western history knows that there was a big drought in the 50s and 60s that centered on the panhandle of New Mexico and out into eastern Colorado and Kansas. And lo and behold, that's what happened in 2013 with the current drought. And you all know about the California droughts. In California, by the way, it's raining a lot right now and snowing in the Southwest. Again, another joke, because it seems whenever I talk about drought, we get a lot of precipitation. But it's been very dry in California and very dry throughout the whole Southwest. And this is serious doo-doo. And one of the reasons it's serious doo-doo is because it's threatening the flows in the very lifeblood of the Southwest. The sustainable water for the Southwest comes in the form really of two big rivers, the Colorado River, which has headwaters in the Rockies, and the Rio Grande, which flows through New Mexico, which has had headwaters in the same place. And both flows in both of these rivers are going down dramatically. Since 1999, there's been a 20% reduction in flows in the Colorado. And the two biggest reservoirs or storage units on the Colorado, or the two biggest in the United States for that matter, are both now less than half full, Lake Mead and Lake Powell. And so they're very close to crisis stage, where water use or deliveries will be curtailed, starting with New Mexico or Nevada and Arizona. Okay, but it's not just in the Southwest. This work came out last year, 2020. A horrible year, right? Well, this news wasn't so good. The Missouri River is the driest in 1,200 years. And the drought there has been going on for nearly 10 years. And when I was thinking about that with my colleague, Brad Udall, we wrote a paper to really put it in perspective. And our thesis in this work, based on observations, models, and theory, is that the whole of North America is aridifying. And you'll see what I mean when I get to the Midwest. It's not just these unbelievably desert-like droughts but it's more frequent drought, more severe drought when it occurs. And dry spells, for that matter, are no longer just dry spells, they're droughts. And then the other thing I really wanted to highlight to you is that as the surface water supply, the sustainable water supply, dries up in the Southwest and other parts of the country, notably the high plains, everybody's turning to pump groundwater. And if people are pumping groundwater, even if they have flows in rivers. In the high plains, the breadbasket of North America, and I don't want to diss, America's dairyland or all the great agriculture we have in Michigan and the other Great Lake states, but a lot of our agriculture is out there in the high plains, and it's not rain-fed agriculture anymore. Increasingly, it's almost all irrigated ag. You see that when you fly over with the circular pivot. And even in Michigan, I haven't looked in Wisconsin lately, but even in Michigan, we're turning more and more to irrigated ag, and using groundwater. And the reason for that is that surface, the rain in this growing season is just becoming unreliable. Where there are always dry spells in the summer, now these dry spells are getting so bad that if you don't have irrigation, you lose your crop, or at least you lose a lot of it. So these aquifers are getting drained. Turns out they're not recharging on human timescales. The water we're sucking out of the ground on these big blobs, and you can see all these colors, are all being depleted. It's mostly water from the ice ages. And as it goes, it's gone. Now, some of the areas, like I think in Wisconsin, might be recharging more than, say, on the high plains or in the Southwest. But nonetheless, the net change in these aquifers is depletion, depletion, depletion. So ask yourself, where are these people going to get their water once these aquifers are no longer producing enough water? I think they'll be going to the Mississippi, the Missouri, and they'll certainly be looking at the Great Lakes, but I think those great rivers are between us and the problem. So I don't think we'll see a lot of water withdrawals from the Great Lakes, which, as you know, can't really sustain it anyhow. All right, well, this isn't just a tale of drought and dry extremes. It's really a tale of two hydrologic extremes. And I want to talk now about the wet side of the hydrologic cycle. Okay, because as the atmosphere warms and holds more water, we say it's increasing the hydrologic cycle. So the extremes are getting more extreme. That means the droughts are getting worse, and they're getting made worse by warming. 50% of what I was talking about, the big drought in the West, is because of the warming, not because of a decrease in precipitation. Should have pointed that out. But you're also going to get an increase in precipitation in other ways. Because the atmosphere holds more moisture, that means in the West, it's demanding more moisture, and it's drying out soils, it's drying out reservoirs, it's drying out rivers, it's drying out vegetation, and that's why you're getting the big increase in wildfires. But when it rains, it actually now rains more in some areas, but more importantly, it rains harder. It's like a sponge. It can soak up more water, but when you squeeze that sponge, more water comes out per squeeze, and in terms of rate. Okay, so that's why, for example, that these big hurricanes now are so much more damaging. It's not the winds; they're definitely damaging, and the most intense storms are getting windier, and you're getting more wind. But the biggest part of the damage, the real cost, it puts it in the hundreds of billions of dollars when you get a big hurricane now. It's because of the rain, the unrelenting rain, combined with the storm surge and the made worse by sea level rise. And then in the summertime, because the Arctic is warming so much, that's also slowing down the atmospheric circulation. These storms tend to go slower, not always, but on average, they have a higher chance of going slower. So they sit there, and they rain harder and they rain longer, and that's a real problem. Let's bring it home to the Great Lakes states, including Wisconsin. Whereas the Southwest and much of the West has been drying out, and you can see that on this map. These are anomalies, the last 30 years versus an earlier time period, 1901 to 1960s average. You can see in the browner colors where it's drying out. And of course, I put a label right over the Southwest, but trust me, Arizona's drying out. But in the Midwest, it's getting wetter. And there are many aspects of this, but what's happening essentially is the storm tracks, particularly in winter and spring, are moving preferentially north. So it's cool to sort of realize that this year it isn't happening so much. I mean, Arizona, until this storm they're getting right now, has been bone dry for a year, but we're getting a lot more precipitation in Michigan and parts of Wisconsin, I look at Iowa and Minnesota. I mean, it's really increasing. And it's increasing on the order of 10, 15, 20% in some places, over 20%. So that's one big change you get when you have an atmosphere with more moisture in it. Where it rains more. It also rains harder, as I said. And you see this around the globe now. And we knew all of these things that I'm talking about are things that climate scientists, some cases me and my colleagues, in other cases even climate scientists a generation before me, predicted would happen. But of course, now we actually can observe them all. So we get a sense that our climate models are pretty good, our theory is pretty good. But this is what's happening too. In the Great Lakes region, the heaviest, we are getting now 42% more of our rain in the heaviest 1% of the storms. And so you're seeing this in a number of impacts, notably flooding, particularly in the spring, when you combine sort of snowmelt and just more rainfall with more intense rainfall. And in Michigan, it's been tough for farmers because hard to plant when your fields are flooded and too muddy to drive a tractor on. Obviously, we were in the news in 2020 with major dam failures in Michigan. And what we have in the Midwest is a lot of infrastructure that is old. It's from the heydays when we were the manufacturing center of the nation. But now the storm water systems, the dams, so much more were designed for a climate that we no longer have. Sort of a more meek and not as wet a climate, not as intense rainfall. So now we're overwhelming our infrastructure. And when the new president of the United States says build back better, one of the things we got to do is make sure that we build back for the new climate, or the climate we're gonna have, rather than the climate we had in the past. And we're getting more flooding, obviously, with the more extreme precipitation. Something else we're getting, though, is that in Wisconsin, this is a problem, as well as across the Great Lakes and really around the world increasingly. But the poster child for this problem is Lake Erie. We're getting more intense precipitation, particularly in the spring. And what that's doing is it causes more runoff from farmland. And that runoff from farmland is carrying excess fertilizer nutrient, manure nutrient into our waterways. This is happening to small lakes. This is happening to rivers, streams, and it's happening to the Great Lakes. Increasingly now we're seeing this around the Great Lakes, particularly in the shallow areas, because these algal blooms, in some case toxic algae, are favored by warmer temperatures. So you tend to see the shallower water warming up more in summer, and that exacerbates the problem even more. But you have a perfect storm with more nutrients and warmer temperatures. And so, for example, we've seen this recently in Lake Superior. We're seeing it in coasts of Lake Michigan. And, I'm sure all of you have seen a lake in Wisconsin that is eutrophied. It's green. And a lot of that is just because of too many nutrients getting into that lake. And if it's adjacent to farmland, that's probably why. It's very hard to control this. Although we're learning how to farm more with an eye towards this. So we're learning how to adapt to the climate changes that we're getting. But adaptation will only take you so far. If we don't start the climate change, eventually all the Great Lakes will look like Lake Erie, at least in the shallow coastal areas, which of course is where we like to recreate and make livings. So the warming so far, 1 degree C. And when you talk to climate scientists, and I am one, if we don't do anything about climate change, if we let it go unchecked, we'll warm the planet, we'll warm the whole planet up 3 or 4 degrees by the end of the century. Plenty of fossil fuels. That's the main cause of the warming, burning of fossil fuels. We'll warm the planet up 4 or 5 degrees. That means in Wisconsin and in Minnesota and Michigan, we'll warm up more than that. We'll warm up 5, 6, 7 degrees C. So the warming will be on the order of 4 or 5 times what we've had already. And the impacts, therefore, will be that much worse. So I want to take a peek at why climate scientists are warning that the warming must be limited to 1.5 or 2 degrees C. Frankly, I don't think we can do it to 1.5. I'm going to continue to fight like hell myself, and what I can do to advocate for that in my own personal carbon footprint and stuff. But we're going to try really hard to keep it down to 1.5 to 2 degrees C. And even if it goes up to 2 degrees C, we can bring it back to 1 point. Why are we so obsessed with this goal? Well, I was asked to talk about brook trout. And that could be one reason. You have to think about what matters to you, what matters to your family, what matters to your livelihood, what matters to your state and your neighbors. It might be you're got friends out in a farming community, and their farms are literally at risk. You might have folks that are living up in the woods, and the same kind of wildfire problems we are having out west now because of the unbelievable heat and dryness. We're going to start seeing that in Wisconsin and Minnesota and Michigan. You might have a lake, a river that you don't want to eutrophy. You might be a fisher, and you might like fishing. You might like these trout. So what's going to happen to the fish? And I've actually done some research with a fisheries ecologist out in the Southwest, and I thought it'd be fun to find a paper and read up on what's at risk in Wisconsin. And lo and behold, someone has studied that. And it was a paper published in 2019 and has colleagues from Wisconsin. And what you're looking at here are 2 maps. And this is sort of where the brook trout live. And this is all simulated using modern climate data on the left, or 1960 to 2000 climate data, essentially present, and mid-21st century based on climate models on the right. And you can see there's a scale in the lower left corner, and the green colors are where the fish are happy. You can see the driftless area moving, up north to where you guys are. And you can see up on the UP of Michigan and some other places, Apostle Islands, on the mainland off the Apostle Islands. You can see a number of places where the habitat is just perfect. And these models verify pretty well, probably not everywhere, but at the 80 to 90% level with what's observed. Okay. So if we warm the planet up, not 4 or 5 degrees like I was talking about, but let's just warm it up 2 degrees by mid-century. In Wisconsin, that means a little more. You get a situation that's on the right. And you can see all those places that were green, like in the driftless area, almost all of them are no longer green. They're yellow. So the favorability, the suitability for brook trout goes down. What's happening? Everyone who fishes trout knows that they're a cold water species. And in the driftless area, you have the groundwater that is buffering the summer temperatures. That groundwater, because it's such a karstic region, it's cold groundwater. And it's getting into springs and getting into the streams, and it's helping keep those streams. But what's going to happen as we go into the future, more and more, is it can be overwhelmed by the warming of air temperatures. And I found it interesting when I looked at this map. I've long wondered why Wisconsin didn't get the UP and Michigan did instead. And I don't want to start any kind of unrest here, but I'm proud of the fact that at least there'll be some trout fisheries up in the UP, and it'll be easy for you to drive to them as well as me. Of course, hopefully what we can do is keep this from happening. But this is what's at stake if you're really interested in fish. Interesting, brown trout habitat is hit less hard, but as you all know, there's less brown trout habitat now anyhow in Wisconsin. All right, that's not really why climate scientists are all up in arms. A lot of climate scientists like being outdoors, like to fish, but that's not why we're really worried. What we're really worried about are these tipping points. You've probably heard of tipping points. What is a tipping point? Let me give you an example. Okay, this is a paper that was published recently, 2019, and it talks about climate tipping points. And what climate tipping points are, it's a threshold in the climate system where if we warm the planet up and cross that threshold, is that threshold at 1.5 degrees global warming or 2 or 2.5? Honestly, we don't know, but I'll tell you, we have some good clues. If we cross those thresholds, then the planet will enter in a period of irreversible additional warming due to what we call positive or amplifying feedbacks in the climate system. Now, what do I mean? Probably you've all heard that the Arctic is warming more than the rest of the planet. I used to work a lot in the Arctic, particularly in Eastern Canada, Labrador, Baffin Island, and in Greenland. And I can tell you, it's unbelievable what's happening up there. Very few scientists, I'd like to say no, but almost none of the scientists I work with in part of the international Arctic research community thought it would warm as fast as it's warming. We knew it would warm faster, but we didn't know it would warm this fast. We didn't know the ice would melt back this fast. We didn't know that we would reach these tipping points as fast as we seem to already be reaching them. So I want to ask you, what are those tipping points? The Arctic is warming, and it's a positive feedback. That's the letter B on this graph, because as snow and ice melts, more radiation from the sun in summer can hit the land surface or hit the ocean instead of being reflected by the snow and ice, which is white. It's being replaced by dark blue ocean or land, brown, or green where there's vegetation. And what happens then is the more radiation stays in the planetary system. It gets re-radiated from the land surface into the air and trapped by the greenhouse gases. Okay, so that's why the Arctic is warming faster than the rest of the planet. But then you have the letter H. What's going on there? Well, that represents permafrost. And all across North America, Alaska, Canada, all across Northern Europe and Eurasia, Russia, there's permafrost, frozen soil. It's been frozen for thousands of years, since the Great Ice Age, in some cases, even before the ice ages. And what's frozen in that soil? It's organic material. It's been just piling up, and perfectly, it's like in your freezer, their planetary freezer. What's happening is that permafrost melts now, is it starts to release the organic material, which is now decayed, and what's being released is CO2 or carbon dioxide and methane. If it's wet, the soils are wet, it's methane. If the soils are dry, it's carbon dioxide. Either way, you have very potent greenhouse gases that start to add to the greenhouse gases that we're putting up there. So it amplifies the warming. And then that puts in a vicious cycle because that warms more, melts more permafrost, warms more, more greenhouse gases, warms more, melts more, melts, releases more greenhouse gases. You sort of see what I'm saying. It turns into this amplifying cycle. Also, you got something going on over at D. Actually, D represents the whole circumarctic region again. What are we getting? Remember the fires that I mentioned at the very beginning of this talk. When you get these gigantic wildfires, whether they're in the Western United States or they're up there in the Arctic, what are they doing? They're releasing carbon to the atmosphere. They're releasing soot to the atmosphere. Soot also warms the atmosphere because those black particles in the atmosphere absorb radiation from the sun. So we're really playing with fire here. I like to think that it's sort of like, you don't know anything about guns, but you've discovered a gun down in the basement. You don't know anything about bullets, so you don't know if it's loaded or anything. You're sort of looking at this thing wondering what it is, and you're not sure how it works, but it's loaded, and someone can really get hurt. And in this case, the planet could get hurt. So there are a lot of these tipping points in the climate system that can do this. And what scientists are worried about is if we warm the planet more than 1.5 degrees, or maybe it's 2 degrees if we're lucky, we're going to get these tipping points. We're going to cross them, and we're going to warm the planet up to 4 or 5 degrees, and there's no way to stop it. So by now, I've kind of, I think, bummed some people out. But I want to highlight that there is hope. There's actually a lot of hope now in 2021, because we have an administration that really is taking climate change serious. If you're a climate scientist, I'm not talking politics here. I'm just talking about, I know in my heart, in my soul, that this is a real problem. And I believe it's a worse problem than most people think. I've been studying this ever since I was in college in the 1970s. In other words, if there's anything I know, climate change is real and it's a real problem. But I also know that there's solutions, and these solutions are in hand. They're also getting cheaper fast. It's not like coal and oil and gas commodities. These things are more similar to your big screen TV. Probably all of you can remember back in the day when you first saw a big screen TV and you said, wow, only rich people can buy those things. And now they're much less expensive. The same thing's happening to all the clean tech, whether it's a huge wind turbine or it's solar panel or batteries or electric vehicles. All of these things are getting cheaper and cheaper, and they're getting cheaper fast. There's also a lot of co-benefits. When you get off of fossil fuel, the air is also going to miraculously get much cleaner in our cities. And this is particularly bad in some of the less affluent countries, but even in like Detroit and Ann Arbor, where I live, our air is pretty dirty. And it's because of internal combustion engines, and it's because of burning coal, and it's because of burning gas, natural gas. It also turns out that burning the fossil fuels is more expensive. So already just about everywhere, renewable energy is cheaper than fossil fuel energy. Renewable electrified mobility over the lifespan of a car or a bus or a truck is cheaper now than an internal combustion vehicle. They're still more expensive to buy, but they are cheaper over the life cycle of the entire, of the car, including the materials that go into building them, including the materials that go into building the batteries. So the key thing here is you get cheaper energy, cheaper transportation, cleaner air, and you can solve the climate crisis too. Of course, lots of jobs. The reason I like to emphasize the jobs, and I suppose President Biden is doing this too, is because if we do this right, and I think, in Wisconsin, you're going to start working hard to capture the market for some of these technologies and knowledge that are necessary. That's what we're doing in Michigan. We are going to be the car provider of the world for the future, and everybody is decarbonizing. So everybody's going to buy electrified mobility. Everybody's going to be buying cleaner energy and all the other solutions that are necessary to do this job. So whoever does it first, whether it's China or the US, Michigan or Wisconsin, India, they're the ones who are going to have the most jobs. So we have an opportunity here to save our own skins, save our trout, or whatever else you care about, and have a kick-ass, excuse me for the French, economy. So to conclude, we know with high confidence that climate change impacts are mounting fast, even with just 1 degree C global warming. I can tell you, we know this as well as gravity. It's that well known. It's like going to the doctor and you have a problem, a serious problem. And the doctor says, I know exactly what the problem is, and I know exactly how to cure it. You all know what it's like to hear that versus the doctor that says, hey, I'm not sure what it is. I'll give you some painkillers and just come back in a couple of years. You don't want to treat the symptoms. You want to treat the cause. In the Great Lakes region, Wisconsin and Michigan, as well as across this nation, the impacts on water supply and aquatic systems are already among the largest. They're also large in the marine realm, where we haven't talked about the ocean warming that's going on. 93% of the global warming heat is going into the ocean. The oceans are acidifying. It's going to be really bad in the oceans if we don't stop it. Okay? And we're approaching these irreversible tipping points. Once they occur, yeah, they can reverse on geologic timescales, but that doesn't do us any good or our kids or our grandkids any good. And there's a lot of change we're going to have to adapt to because we are going to warm another half degree. We're going to have to learn how to maybe plant more trees along streams if you care about trout, or shade. You're going to have to learn maybe other technologies or just management skills to keep the fish in the water or to farm and still be productive. But at some point, it's all going to be overwhelmed if we don't stop the climate change. So with that, I'd like to stop. And if we have time for questions, I'm really happy to answer them. Thank you very much. You can follow me on Twitter, by the way, and get more of this stuff if you want.
Thank you so much, Dr. Overpeck. As he mentioned, we'll open it up to questions. So if anybody would like to ask anything, feel free to type it in the chat, and that will get to us, and we will read it out loud and then answer it.
No questions.
Probably just taking a minute for people to type them out. So I have one question for you while we wait. You mentioned about some of the different trajectories and how we were hitting them sooner than we anticipated, particularly in terms of the Arctic melting and things. Do you feel there are other trajectories that we've been hearing from, media or climate scientists that we are actually going to hit sooner than anticipated? Like, should we be even more concerned about the climate crisis than many of us already are?
I think so, unfortunately. Another one that really has me worried is the burning of tropical forests. The Amazon is the one we always hear about. And the current government of Brazil and Bolsonaro, the president there, is trying to speed the development of the Amazon, meaning cut down the trees and bring in livestock and in some places farm more. And the trouble with that is that forest is an amazing terrestrial carbon sink. So about a third of the, to a half even, no, about a third of the carbon that we emit into the atmosphere gets taken up by vegetation and the ocean. And if we convert the tropical rainforests across the whole globe, in sort of Brazil, the Amazon, as well as in Africa and Southeast Asia, all of a sudden the biggest terrestrial carbon sinks in the world will no longer be taking up carbon. They'll start to emit carbon. because with the fires and just the soils will start to lose all their carbon to the atmosphere. And so that's another one. And I've worked in the Amazon, and one of my things that I've discovered with my grad students is that the Amazon actually is drought prone too, and it's drying out. And so even if we are, so if we're not careful, these fires will start naturally. If we have a drought that lasts more than a year. The longest drought we've seen in the Amazon recorded history is a year. But if you look at the paleoclimate record of the last 1,000 years, we've had droughts that last a decade. And the forest is to survive those because there's no one there to start fires. But what you see across the globe now is, you got people that are really, poor, or they're just industrialized farmers. It's a range. Palm oil is the big thing in Indonesia. If the forests dry out, they're not allowed to clear them legally. But if they dry out, they can just throw a cigarette on the ground and they can burn out the forest. And then lo and behold, next thing you know, they got a farm. So it's a real problem. And I'd say those are the biggies. The Arctic and the tropical forests are the ones I worry the most about.
You mentioned that you've presented to Congress and things as part of the IPCC and the Nobel Prize. I'm curious, over the decades that you've done this type of work, do you feel like politicians are starting to listen at all, or do you feel like it's kind of the same thing we've been telling them for many years?
Absolutely, people are listening. I mean, there's a great several groups, some that you've heard of, like Gallup and things, but they're actually researchers trying to look at public opinion and also political opinion on this issue. And right now, the public opinion in the United States is amazingly pro it's real. I think it's like 70-80% of Americans now realize, 70, let's say, let's not go too far, believe that the Earth is warming, that it's warming at least in part due to humans. And then a majority of Americans believe we need to do something about it. Even in Arizona, which until recently was, a totally red state, it makes other red states look kind of wimpy. The public really believes in climate change. And the reason they do is because they can feel it. Everyone in Arizona knows it's climate change is happening. Now, your question was about politicians, though. And politicians aren't always listening to the public and the constituents. They're listening to the special interest just as much or more. And so the oil and gas industry, it used to be coal too, has an amazing amount of money and an amazingly sophisticated infrastructure to make sure that as many politicians as they can are actively fighting climate action. I think this is part of what was going on with President Trump. He was clearly beholden to oil and gas. He did everything he could to help those guys. And one of the things he did was, really roll back climate action. And, for example, the Paris Agreement and quite a bit more. So, yeah, there's still, particularly in the GOP, quite a few politicians that are listening instead of listening to their constituents or Mother Nature. They're listening to big oil. And it's unfortunate. And the auto industry here in Michigan used to be really trying to keep climate action from occurring. But there's been a dramatic flip in that. And with that, a lot of Michigan politicians are now, conservative or not, are, pro climate action, because Michigan's going to probably clean up as we go to electrified mobility around the world.
Thank you. One of the questions that came in is looking for some clarification. Did you say that Wisconsin is getting drier, but we are getting more rain?
Yes, that's a great question, because it's paradoxical, isn't it? On one hand, we're getting more average annual precipitation. And it's gone up, in Wisconsin, about 10% on average. And which, from a climate scientist point of view, that's a lot. It could be a lot more, and it will be a lot more, but that's a lot. But that water you're getting more in the winter and in the spring. And you'd say, well, wait a minute, we're not getting more snow. Right, you're getting more rain in the winter. That stinks if you like snow like me. But you're getting more precipitation, mostly in those seasons. But then in the summer, you're getting the effect of the temperature. And even though you're getting maybe more precipitation, not that much more in the summer, but you're not losing it. But because it's getting hotter, it's getting drier. And so just about everyone probably watching tonight has had a garden. And in summer, you know what happens on the really hottest days. You know, your plants start to droop a little. You water them more. And that's exactly what's going on in summer. It's, because the atmosphere can hold more moisture when it's warmer, it's demanding more moisture from the soil and from the vegetation. And the plants, as a response to that, wilt. The soils dry out. The streams and rivers dry out. And so, in my youth in the Midwest, which was a long time ago, I was an Iowa, Michigan guy, you get the dry spell. You get that week of, dry, no rain, maybe your mom and dad would complain about, make you go out and water more. But it wasn't that bad. But the trouble is now you're getting something, those are turning into what we call flash droughts, where it turns into something a little more serious. And that's why we're having to go and pump groundwater and irrigate, because you just can't be sure your crop's going to get through the summer without the irrigation and be a good crop in many cases. So yeah, it's really something, isn't it? It's all because of warming that we're getting more moisture demand by the atmosphere. And then when it rains, which is primarily in the winter and spring, you're getting more. So it is really wet. And it's cool, though. And so you feel the effects of the flooding and everything.
The next question is, years ago I recall reading about disruption of the Gulf Stream. Do you know what the current thinking is and what models say?
Yeah, that's a fun one. I don't know if I can go back to my talk, but if you remember in my slide when I was talking about, I showed you the map of 2020, the trend in warming. Everywhere in the globe where we're measuring pretty much is red or yellow. It's warming. That's why we're calling it global warming. There's nothing fancy about that. But there's one place on the planet that isn't warming, in the North Atlantic. And this was predicted, again, back in the 70s and 80s. And it's predicted that the Gulf Stream, it's a little more complicated than that, but essentially the Gulf Stream, which plays a role in the climate system to move heat, because most of the heat in the planet is down near the equator, the thermal equator, right? Because it's getting more sunlight more year round. That has to move northward in both hemispheres. And half of the heat moves northward by ocean currents, half moves by atmospheric wind, an atmospheric motion. And that's what the whole planet, we're on a spinning planet. That's why we get weather and Coriolis effect and all that. Well, anyhow, the Gulf Stream is one of the primary ways that heat gets moved north from the equator up through to the North Atlantic. And that's slowing down. And so as it slows down, you're getting less heat transported in the North Atlantic. And so the North Atlantic is cooling. So it's the one place on the planet that is cooling. And as global warming gets bigger and bigger and bigger, it won't be cooling anymore, but it'll be warming less. And that can have some implications, particularly if you're downwind of the North Atlantic. A little less global warming, that air travels over the North Atlantic. It's not as hot. So it might be okay. But it also means, unfortunately, Great Britain is now starting to get hurricanes. The hurricanes can go further north. And they're not called hurricanes when they get that far north, but they do the same kind of damage. Big rains and everything like that. So it's not necessarily a good thing. But to me, as a climate scientist, it's one of those things that was predicted a long time ago based on models and is happening. It's very interesting.
Thank you. We are just about out of time, so I just want to once again thank you, Dr. Overpeck, for your time tonight. We are so thankful for all of the knowledge you have shared with us and all of the work that you have done researching and advocating that we address climate change over the years. And before we go, I would just like to once again highlight for all of our viewers the next event in this series is next week, Thursday, February 4th at 6 p.m., and it will feature Lieutenant Governor of Wisconsin, Mandela Barnes, speaking on the Wisconsin Climate Task Force. So if you have any questions about this climate change series or any of our other presentations, please feel free to email sustainability@uwrf.edu, and we will get you connected with what you need to know. Thanks, everyone, and have a good night.
Thank you.